Okay, this video is about the chi-square test for independence. Last class we talked about chi-square test, and it was for goodness of fit. That tested a observed distribution against a claim distribution, and this is a little bit different. So this is used to determine whether there's a relationship between two categorical variables. I have an example here with student attendance and data. I could take data on students who have always attended and who have skipped, and then check to see if they passed or failed their exam. And to do that, I would put it in what is called a contingency table. So if you attended and you passed, that would be the number that I have recorded for that. And attended and fail would be in the attended column row, fail column. Skipped but passed would be in the skipped row, pass column, and skipped but fail would be in the skipped row and pass column. So for a hypothesis statement, the null hypothesis is always that the variables are independent, and the alternative hypothesis is that they are dependent. This is always the case, so that's great. That means it's easy to remember. So in the instance of my student attendance and exam data, I would just say that attendance, my null hypothesis would be attendance and test statistics are independent, and my alternative hypothesis would be that my attendance versus my exam data is dependent. So one thing that we would need to be able to calculate our expected frequency. These are our observed frequencies, so I would need to be able to calculate expected frequencies. And to find the expected frequency, so these are rows and these are columns. I would need to multiply the row by column total and divide it by the table total. So in this case, I would need to find a row total, column totals, and then a table total. So across my row here, I have 25 and 6, so that is a total of 31. And then my skipped data is 8 and 15, so that would be 23. And then down my pass column, I would have 25 and 8, that is 33. And then down my fail column, I have 6 and 15, so that's 21. And then my total here, I could add down this column here, or I could add across the row here to get my total. Those numbers need to be the same. And if I add across the row, I have 54. If I add down the column here, I also have 54. So that means everything is good. So if I want to find my expected frequencies, I'm just going to label that X. I need to multiply 31 times 33 and divide it by 54. And that gives me 28.7. All right, so now for this entry, attended but failed, it's 31 times my column total times 21 divided by 54. And that gives me 12.05, or 12.1. We'll round up. All right, and then for my skipped but passed, it will be row times column, so 23 by 33 divided by 54, for a total of 14.1. And then for skipped but failed, it'd be 23 times 21 divided by 54. for a total of 8.94. Okay, you'll see that I left my expected values in a data table the same size as my observed values. And then to perform the chi-square, to find the test statistic, it's the observed minus expected squared divided by the expected. That's if you're going to calculate it by hand. So the degrees of frequency here are a little bit different as well. It's the number of rows minus 1 times the number of columns minus 1. So in our case here, we have 2 rows. Our degrees of frequency would be 2 rows minus 1. And then we also have 2 columns, so 2 columns minus 1. And that's 1 times 1. So our degrees of freedom in this case are only 1. And all of our expected values have to be greater than 1, and no more than 20% of the expected frequencies are less than 5. We have a different test for that if that happens, but we won't be doing that in this class. So in order to do this on a calculator, you're going to have to use something new on your calculator. It is called a matrix, or a matrice. And if you look on your calculator, if you look at the second button and you count down, the fourth button down has an x to the negative 1. If you use second function underneath that, so this button says x to the negative 1, on top of that is something called matrix. That's where we're going to put this data and this data when we perform a chi-square test. Why don't we go ahead and write down our null hypothesis. So the null hypothesis is that attendance and test data are independent. And then the alternate hypothesis would be that attendance and test data are dependent. Okay. I need to find my critical value, so I need to go and look at a table with 1 degree of freedom. We should figure out that since we're not given a alpha here, that we're going to use alpha equals 0.05 because we don't have, we're not given one, so that's what we default to, and that is in this region. And from the table, I get a critical value of 3.841. That's 1 degree of freedom with an alpha of 5%. All right, so I'm going to go to my calculator and enter into a matrix. So you do second matrix, and then you hit enter when you for A. You're going to choose matrix A first. So A, let me erase some of this so I can have somewhere to write. Okay, I'm going to write up here. So in matrix A, it looks like this. You hit enter. Actually, no, you don't. Just kidding. You have to quit and go back to matrices if you did that. You have to go over to edit first. Okay. And up at the top it says matrix A. Mine says 1 by 1. I don't know what yours says, but mine says 1 by 1. That means it's 1 row by 1 column. I'm going to change that to 2 by 2. So now I have, sorry about that, that was my teenage son tromping down the stairs looking for, you guessed it, food. All right, so back to what I was saying. Up at the top, you're going to change that so that it says 2 for 2 rows by 2 columns. So you should see across the top of your calculator, matrix A, 2 by 2. And it will open up a spot for you to enter in these pieces of data. So in matrix A, I want you to type in, you're going to need to arrow down. After you enter this, arrow down, and that'll give you the first spot to put in your data entry, and you're going to put in 25, and then it goes to the next spot and you're going to put in 6, and then it goes over to the third spot below the 25, and you're going to put in 8, and then in the fourth spot you're going to put in 15. And then I want you to quit. You must quit after. So that's second, and then the quit button is above the mode. And we're going to do the same thing now, but we're going to edit matrix B. And in matrix B, we're going to put the expected data. So this is in matrix A. And now I want you to go back into the matrix menu. So you're going to press the second x to the -1, and you're going to go over to edit, and you're going to then, when you're in the edit menu, you're going to scroll down to B. And when you get matrix B at the top, you're going to change that to 2 by 2 as well. And then you can type in 28.7, 12.1, 14.1, and 8.94. So that'll be in matrix B. All right, once you have your data in your calculator, quit. I'm going to erase all of this stuff again, so I have more room to write. This looks a lot more complicated than it really is, but I go into stats, tests, so stat, test, and then I'm going to scroll down until I find chi-square. And that just looks like this. It's not the goodness of fit test, it's just the chi-square test. And then when you choose that, you're going to see observed and expected, and it should default to A and B, matrix A and B. And all you need to do is select calculate. And when I did that, my chi-squared value is 11.7, and my p-value is essentially 0. So since the chi-squared would be to the right of my critical value. That means it's in the critical region, and the probability is pretty much 0 that this would happen by chance. So we would reject this hypothesis, reject the null hypothesis. What a relief. And to think, because I would hate to think that I had just been imagining that if students skipped class, they did worse. All right, I have one more example for you. The first thing that you need to do is calculate the expected values. So I went ahead and did that. I have 430. I'm just going to write them in the same table right next to the observed values. So 435. I'm going to leave that because even if I round it, it's 0.0. 743.4. 184.6. And then this would be, oh, I probably should go and write down my totals first. That was 919, 676, 1676, 390. And when I total that up, I get 2985. And across the bottom, I get 1413, 256, 586, and 730. And remember, it's row total times column total divided by the total. All right, so this row would be 919 times 256 divided by 2985. I'm going to go ahead and write all of these down. I'm going to pause this and write it down so you don't have to listen to me write down the numbers. Go ahead and calculate them yourself. All right, I've gone through and added all of the expected. So this would be observed, and these would be my expected values. All right, so to figure out how many degrees of freedom I have 1, 2, 3 rows. So I subtract 1 from that, and I multiply by the number of columns minus 1. So in this case, I have 1, 2, 3, 4 columns. So 4 minus 1, that would be 2 times 3. So I have 6 degrees of freedom. Now I can look up my chi-square test statistic. I am given an alpha of 0.05. So with 6 degrees of freedom and an alpha of 0.05, I get a value of 12.592. And I know that chi-square isn't symmetrical, but just to help those who need a visual, I would have 5% in this end here. That's the critical region. Chi-square alpha is 12.592. Okay, the next thing I need to do is I need to enter in matrix A all of the observed values, and matrix B, I need to enter all of the expected values. So you're going to go back into the matrices and you're going to do second matrix, which is x to the minus 1 after you hit second. And then you scroll over to edit. Now we still have stuff in our matrices from last from the last example, that's okay. We can't erase a matrix, we can only write over the top of it. So when you go over to edit, you choose matrix A, and we have 3 rows and 4 columns. So while it's up at the top there, you're going to enter a 3 and then a 4. And you'll see that your old data is still in there, but now you have additional space to put stuff. You're just going to type right over the top of your old data. So you're going to put in, first you're going to put in 600, then 63, then 112, then 144, and so on until you get all of the observed values in. Once you get your observed values in, I want you to quit. So that's second, and then you push the mode button. If you don't quit, you're just going to keep editing in there, and so it's important that you quit in between. All right, now you need to go back in, and we're going to edit again. So second, x to the -1, and this time we're going to choose matrix B. Oh, first you have to go to edit. Sorry if I messed you up. So go to edit and then go to matrix B and do the same thing. While you're there, do 3 by 4 and enter all of those observed values in. Pause this while you do that and turn it back on when you're ready to run the test. Okay, now that you have entered all of that in, you can go into Stats, Tests, and scroll down until you find chi-square. Again, all you have to do is hit enter and enter, because you should have matrix A and matrix B as your observed and expected matrices. And then you just hit enter for calculate. Okay, so I get a chi-square of 224.1 and a p-value of 0. That is definitely in the critical region. 224 would be 0. Snowball's chance in hell. So we're going to reject our null hypothesis. It appears that the relationship between marital status and happiness is definitely dependent. All right, that's it.